Right now, I'm doing something that might be quite peculiar in the entire universe. Yes, it's speaking. When you think about it, this is truly incredible. You might say language is powerful, yet its transmission efficiency is so low that even aliens in a rural classroom would complain. Keep in mind that on our very own planet, squids can communicate directly through changes in their body coloration. There are even creatures like siphonophores that can communicate directly at the level of thought through physical neural connections, assuming they possess thought. That is, but then, if you argue that language isn't powerful, there are countless animals on Earth that use sound to communicate. Yet, only humans have developed a logically complete sound-based information encoding system. So, the act of purely using sound to tell a story, as I am doing now, is nothing short of an evolutionary miracle. So, how did language evolve? Frankly, the academic community still has no definitive conclusion on this. After all, it's incredibly difficult to find the sounds of time preserved within those silent bones in the strata. However, this isn't a completely clueless endeavor. So today, based on the limited evidence available in this field, combined with a bit of my personal speculation, I will attempt to unravel the origins of language with you. The story begins in Africa, over 30 million years ago. At that time, Earth had just plunged from the warm Eocene into the frigid Oligocene. Forests across the globe rapidly collapsed, nearly wiping out all primates worldwide. This event is known as the Eocene-Oligocene extinction event. Africa, being an overall tropical continent, became one of the few remaining regions in the northern hemisphere with vast forests. It was here that the surviving primates took a crucial evolutionary step, getting bigger. Originally, most primates were small, arboreal animals roughly the size of today's squirrels. But 30 million years ago in North Africa, the Egyptian Phaeum primate, which could exceed half a meter in length, emerged. This increase in body size led to a series of fascinating developments over the next 30 million years of evolution. Initially, the direct consequence of increased body size was that a group needed more expansive territory to survive. Thus, a monkey troop could no longer gather and move within a single cluster of branches as before. However, visibility is limited in the tree canopy. So even if group members were not far apart, it was easy to lose sight of each other. Furthermore, our suborder within primates, the Strepsirrhini, had degenerated the typical mammalian wet nose, significantly weakening their sense of smell. So, for group members to locate each other, wouldn't communication rely entirely on shouting? In any case, after getting bigger, their natural predators also significantly decreased, so a few shouts weren't a problem. Even today, monkeys and apes are constantly vocalizing. For example, the howler monkey, similar in size to the Egyptian Phaeum primate, is a prime example of this. Since our primate hearing isn't top-notch, the ancestors of us, as well as chimpanzees and macaques, among others, evolved a pair of air sacs in their throats, known as laryngeal air sacs. These air sacs not only help bear some of the air output during shouting but, more crucially, can act as a resonance chamber, making the sound higher-pitched. This high-frequency sound has excellent localization properties, allowing them to declare their position more precisely. And coincidentally, primates have abundant facial muscles. Originally, monkeys communicating face-to-face would display a rich array of expressions. The process of opening their mouths and widening their eyes inevitably produced sounds. Now, these high-pitched sounds gave them an added layer of communication. So, some monkeys realized, why bang on tables and kick legs when you can just move your mouth? This avoided a lot of unnecessary internal conflict. Modern neuromedicine has also found in clinical practice that many patients with damaged language centers in the brain struggle to speak smoothly, but as soon as they start spewing profanities like cursing someone's mother or referring to someone's ancestors, their tongues suddenly become nimble. This suggests that cursing might form our most fundamental linguistic configuration. So, I often wonder, if humans could understand animal speech, the chirping of birds and the cries of apes in nature must sound utterly fascinating. That said, even with vocalization, it doesn't mean language evolution had already established its core framework. After all, even today, whether it's various monkeys or great apes, their vocalizations are relatively limited and naturally cannot convey complex meanings. In fact, most animal vocal communication in reality reaches its peak at this stage. However, right when the ape cries on both banks were incessant, fate was already a small boat striking a massive iceberg. At that time, the ancient African continent was gradually splitting apart. Finally, over 7 million years ago, a massive rift tore through East Africa from north to south. Today, we call it the East African Rift Valley. The direct consequence of this was that a region in eastern Africa became completely isolated. And, unfortunately or perhaps fortunately, it just so happened that our human ancestors at the time were located in this isolated area. Later, with the advent of the Quaternary Ice Age, the climate changed drastically. As a result, the East African coast gradually became drier. The once continuous forest broke up into isolated islands of trees. Our ancestors at the time, the Australopithecines, had no choice but to climb down from the trees they had inhabited for generations and trek across the grassy wilderness to find new forests. What impact would this have on the evolution of human language? That's a long story. In 2000, paleoanthropologists in Dikika, Ethiopia, discovered the fossilized skeleton of a juvenile Australopithecus afarensis, named Salam. Experts speculate that Salam likely drowned during a flood, and her body was quickly buried by mud and sand, leading to a relatively complete skeleton. And it was on this fossil that scientists found a bone that is often missing in other fossils, the hyoid bone. Simply put, this is a small, independent bone not connected to any other bones in the body, located in our throat. Generally, animals use this bone to support the tongue. Most primates, to support their laryngeal air sacs, have a small, flattened protrusion at the front of their hyoid bone, extending backward, like the hyoid bone of a chimpanzee. In contrast, our human hyoid bone looks much more slender. That's right, our laryngeal air sacs completely degenerated. This makes it difficult for humans to produce long, chattering, high-pitched calls similar to those of apes. But conversely, it makes us much better at producing mid to low frequency sounds. Furthermore, without the need to support laryngeal air sacs, the hyoid bone can more singularly attach to tongue movement related muscles and ligaments, thereby making our tongue more flexible and, consequently, able to produce a wider range of sounds. So, what did Salam, the Australopithecus afarensis, hyoid bone look like? After analysis, paleoanthropologists believe her hyoid bone was morphologically closer to that of a chimpanzee. This suggests that Australopithecus afarensis most likely could still only produce ape-like vocalizations. This is understandable. After all, Australopithecus afarensis still spent a lot of time in trees, and not only were they short in stature, but their upright posture on the ground meant they often went unseen amidst the vast, windy grasslands, where the grass was low. So, a few shouts would still have been somewhat useful. However, as humans who lived entirely on the plains, represented by Homo habilis, began to appear, things gradually started to change. These humans were tall, stood straighter, and their bipedal locomotion was largely established. From then on, humans began to constantly see each other face to face. As a result, the need for long-distance shouting diminished, while the proportion of face-to-face communication greatly increased. The original loud vocalizations were no longer well suited for this new scenario. As the laryngeal air sacs gradually degenerated, our facial expressions and body language began to become increasingly rich. One hypothesis suggests that one of the evolutionary drivers for humans retaining eyebrows is that eyebrows, combined with eye movements, can convey more complex emotional meanings. In short, we specifically kept those two tufts of hair for nonverbal communication. This increasing complexity of facial expressions would likely also lead to the increasing complexity of sounds. After all, everyone uses the same set of facial and head muscles. Thus, sounds gradually became an important supplement to expressions, finally breaking free from the expressive system to become an independent system for transmitting information. In this process, a minor, unexpected event might have actually accelerated the emergence of language. Simply put, due to the lack of fruits and tender leaves, traditional primate favorites in the open wilderness, almost all primates who descended from trees significantly increased their proportion of meat in their diet. This was true for baboons in the monkey family, and it was no exception for humans. But the problem was that before their tool-making abilities matured, humans' capacity to hunt large terrestrial animals was truly questionable. Fortunately, the areas where early humans lived were crisscrossed with rivers and lakes, so acquiring fish pond vegetables, i.e., aquatic food, was not a big problem if they couldn't hunt on land. At the famous paleoanthropological fossil site, Olduvai Gorge, a large number of fish bones and turtle shells have been unearthed. Judging from the processing and gnawing marks on them, these were undoubtedly the kitchen waste of many early humans, including Homo habilis. Perhaps it was in their daily lives of diving and fishing that our ancestors unlocked a new skill, the ability to voluntarily control the epiglottis cartilage. This meant they could consciously decide whether their oral cavity connected to the esophagus or to the trachea. This epiglottis cartilage, which could easily be shifted into manual mode, allowed our ancestors to voluntarily breathe at the water's surface and hold their breath underwater. This also brought two side effects: one, we became very prone to choking, and the other, we could also voluntarily regulate our exhalation when producing sounds. This allowed them to utter longer sentences in one breath, and speak for extended periods without running out of breath. All of this granted Homo habilis and later humans, such as Homo erectus, more complex vocal expressive capabilities. Some indirect evidence seems to suggest that Homo erectus was already capable of expressing relatively complex meanings through sound. Compared to the facial expression system, which emphasizes emotional conveyance, the vocal system appears to have, from the very beginning, prioritized logic and narration. Around 1.7 million years ago, a new type of stone tool, known as Acheulean tools, gradually began to appear in the geological strata. Compared to earlier tools, the most distinctive characteristic of Acheulean tools is their clear formal standardization. Simply put, tools before this era were made by haphazardly chipping away, and whatever shape resulted would then be used as a tool based on the situation. Acheulean tools, however, were created with the maker first envisioning what kind of tool they wanted to make, and then producing it according to that pre-designed plan. What's even more remarkable is that despite Acheulean tools being unearthed across almost the entire Afro-Eurasian continent, the forms and standards of Acheulean tools across different regions and eras are quite similar, suggesting some form of craft tradition. It's truly hard to imagine how so many technical details could have been passed down solely through facial expressions and body language. So, did Homo erectus already possess language? Well, I can only say this: while we're not entirely clear what the hyoid bone of Homo erectus looked like, we have found several very fragmented hyoid bone pieces in the fossils of another ancient human, Heidelberg man, who lived about 450,000 years ago. Heidelberg man is morphologically closer to modern humans than Homo erectus, and potentially represents the most recent common ancestor of us, Homo sapiens, and Neanderthals. After expert analysis, these hyoid bone fragments were deemed to be overall more similar to modern human hyoid bones. It seems that Heidelberg man should have already been capable of making sounds very similar to those of modern humans. However, even if Homo erectus possessed a hyoid bone identical to that of Heidelberg man, it doesn't mean these ancient humans already had language, or at least language in our modern sense. This is because vocalization, or vocal organs, are merely the external hardware conditions for language. Beyond that, language also has a software component, our brain's language control system. In two studies from 2016 and 2017, some scientists, after analyzing the laryngeal structures of rhesus monkeys and baboons, concluded that these monkeys, based on their physiological structure, should have the potential to produce a wider variety of sounds, including some vowels and consonants used by humans. Theoretically, they also had the capacity to create their own spoken languages. So, the key reason why apes don't speak should primarily not be their inability to produce sounds, but rather that their brains simply don't support language. In fact, as early as the 1970s and 80s, an era when academic ethics were less mature, some scientists conducted even more audacious experiments with apes. For instance, an American researcher taught a gorilla named Koko sign language from a young age. Reportedly, Koko eventually mastered over 100 sign language words and could use these words to form phrases, telling her caretakers she wanted snacks, to rest, or to be petted, and even expressing her feelings. Another chimpanzee named Kanzi was even claimed to have mastered over 3,000 English words and even learned to type. Ha ha, double, double, toil and trouble, Shakespeare. However, even if the results claimed by these studies are true, they often point out that these great apes struggle to form long or complex sentences. They can usually only express a phrase consisting of 3 to 5 nouns, verbs, or adjectives, often with little grammatical concept, and are consistently unable to grasp the function of prepositions, conjunctions, or modal particles. In reality, neuroscience has long demonstrated that our brain's temporal lobe cortex contains 2 specialized language areas. One area is specifically responsible for precisely controlling the throat, lips, and tongue to produce speech. It's called Broca's area. If this area is damaged, a person will revert to an ape-like mode, only able to utter individual words and short phrases, and find it very difficult to speak coherently. This is known as motor aphasia. The other brain area is specifically responsible for understanding spoken language. It's called Wernicke's area. If this area is damaged, in addition to struggling to understand what others say, a person will speak in a disconnected way because they don't understand their own words. It sounds like they're speaking fluently, but much of it seems like gibberish. This is known as sensory aphasia. As far as we know, these 2 brain areas are unique to humans. No similar functional brain areas have been found in any other animals, including other primates. And this is likely the key structure for the ultimate formation of human language. But frankly, if the evolution of vocalization can still be somewhat glimpsed by observing the hyoid bone's development, the evolution of the brain is completely baffling. Therefore, it's actually very difficult for us to definitively conclude exactly when human language emerged. Some believe that complete language already existed around 350,000 years ago, when Homo sapiens first appeared. Others argue that true human speech only began around 70,000 years ago, after our Homo sapiens ancestors almost faced a group wipeout event. In any case, linguists are still debating it. But regardless, the fact that humans can communicate with each other in this clumsy yet exquisitely subtle way is truly the result of countless historical coincidences aligning. The probability of this is so infinitesimally small that don't you agree it's one of the great miracles in the universe? And we, precisely using this utterly unique mode of communication, have built the only civilization on this planet. Right up to this very moment, allowing you, my friend in front of the screen, to spend over 10 minutes listening to me tell the story of human language, in human language. That makes it all the more ineffable, doesn't it?